Okay, in this video we're going to talk a little bit about how to use WolframAlpha.com in order to sketch graphs. So just learn some of the basics. This is also available. WolframAlpha.com also has a pretty nice iPhone app and probably on your Android as well. So if you're interested, it is a couple of bucks, but it's a pretty neat program. Anyway, we can do a lot of graphing here through WolframAlpha, and this is a nice kind of natural language sort of program. So once you're at the website, you'll get this lovely screen. And let's say we want to graph f of x equals 2x minus 2. We can just type that in exactly the way that we see it and tell it to go. Give it a second to compute, and it's going to come back with a plot of your graph momentarily. There you go. Now, a couple of things to notice about WolframAlpha. We don't have a lot of control over at least with the basics here. We don't have a lot of control over the window that we get. So do make sure that you pay attention to how your axes are labeled. They generally, the computer program will generally kick out two different plots for you. So look at the two different ones and see which picture you think best represents what's going on and which is best to the scale that you want to. So for example, in this one, look at how teeny these numbers are. Over here, it warns you that x is going from 0.98 to 1.02. That's not a very big range. I'm much more interested here in this one where x is going between -2 and +2. So this gives me some points. I notice my y-intercept here is at 0, -2. My x-intercept's here at 1, 0. And I can come up with the different values from there. Once you've got your appropriately scaled values here, you can go over and recreate your graph on whatever assignment it is that you want to be working on. Let's go through and do a couple of other examples, just so that you can see some of the quirkinesses and how things get typed and what things look like. So that was an example of a linear equation. Let's suppose that we want to do a quadratic equation here. Let's try this 2x squared minus 2. In this case, we can just go right back up here, and this time we want to do 2x squared minus 2. Use the little caret key that you see up shift 6 to enter the exponent, and we can tell it to do that. Hit enter, give it a second to do its little thinky. And here you go. And again, just like before, it gives you two different versions of the plots. Here, x is going from -1 to +1, here from -2 to +2. They each give you a little bit of additional values that you can look at. And that's plenty good to be able to answer any questions that you will need to do on your homework. Let's see what else we can find here. More of the, sorry. I wanted to have both of these windows here available for you, so let's take a peek. Lots of quadratic functions. Oh, here's a new one. Let's try doing an exponential function. In this case, we want to graph 4 times 2 to the x power. So we can do 4. When you're doing multiplication, you can use the star button, which is shift 8, to show that you're going to multiply. So here, for example, I want to do 4 times 2, and then I want x to be the power. Oops, why do we do that? Oh, I pushed something way different here. Oops, sorry, just wanted to lose that. So 4 times 2 to the x power, 4 times 2 caret x, and then we can tell it to graph it. Notice really nice here, it writes this out with a more equation-y looking format, so you can make sure you entered things correctly. And again, here we have two different versions of the plot. Here from -4 to +4, or from -4 to 0. Here you can see it going from -10 to +10. So you can get a couple of different views and different scales. Look at how crazy quick it's going up here, right? We're past 500 before we even get to 7 in the x-coordinate. So exponential functions, pretty amazing. If we look here at this example, y equals 6 over x. Remember, we can use function notation. WolframAlpha is just as happy to use y equals when it's doing its graph. So you can go y equals 6, use the slash For your division, hit equals when you're done. And this will give you yet another exciting type of graph here. So let's take a peek here. Again, a couple of versions, one a little more from negative 1.5 to 1.5, and here from negative 7.5 to 7.5. And either way, we can see that at x equals 0, our function is undefined, and nearby it gets crazy, and then it kind of settles itself out in the long run. So we can get all sorts of different interesting function families when we try to graph things. A couple of other ones that kind of wanted to point out, x to the third, if you want to do something like that. Let's just do this, x to the third plus 2. Use the little caret button. Y equals x to the third plus 2. This gives us a new family of functions, the cubic functions. And they do kind of some fun squiggly things when we see those. And again, we can see different zoomed out versions, but here it kind of squiggles, flattens out in the middle and then keeps going up forever, so that's pretty cool. Oh yeah, the last kind of thing I wanted to show you was I think we had some square root graphs on here. And there's not really a square root button when you try to type things in here on WolframAlpha. So there are two ways that we can go about doing that. One is to remember, or to use SQRT. Try again if I can type SQRT, and this will tell us, let's say we want to do the square root of x. So a function type like this. This will take whatever is in the parentheses and find the square root of it. Now, WolframAlpha is an incredibly powerful tool, and it will often do things like show you both real and imaginary parts. And when we're talking about graphing, for the most part, we really don't worry about graphing imaginary portions. But WolframAlpha is super powerful and valuable for all sorts of things. What I usually will do is come over here. Notice how there's an option for a complex valued plot. That means that it's going to include imaginary numbers, which are kind of weird looking. Generally, we're used to seeing real valued plots. So you can click on that real valued plot instead there. You can also change it down here. And now you'll get what is a much more traditional looking square root graph, and that is absolutely nothing showing up here on the left hand side because we can't take the square root of negative numbers, and now this blue piece is the only part that's real valued, so it kind of comes up like this and kind of levels off as, well, it doesn't really level off, but it goes up slower as time goes on when we work on our other functions. So that gives us some additional pieces that we can do. The other way to think about those square root graphs is remember that anytime you have a root, you can write it as an exponent with a fractional power. So we can also graph the square root of x by typing it in as x to the 1/2 power. Make sure that you put that 1/2 in parentheses or the computer will get confused. But this will take x to the 1/2 power, which means the same thing as the square root. You can double check it because it'll write it in the nice version there. And again, anytime that it has those red plots showing up, you can ask it to change to a real valued plot instead, and that will give you the new values as you go. So I think that covers just about the main things that I wanted to cover with that. So with that, you should be able to get those basic graphs for any function that you're interested in looking at. So a lot of super powerful functionality there, and some pretty neat things. Notice there are links here for enabling an interactivity. There are some, WolframAlpha is definitely a paid company, and so they will ask you to pay for that. But in terms of what I'm expecting you to do in class, you shouldn't have to pay for anything and just use this free functionality here on the graphs as you go through. I think that should do it.